make sure you understand like all the parts of this, which is why I spent time changing it from just regular multiple choice into like different breakdown parts. So first of all, this is a cross multiply question. That 14 is multiplying with the 2x plus 2. That 12 is multiplying with the 2x plus 5. And the parentheses are necessary because 14 is multiplying with both parts. 28x plus 28 is equal to 24x plus 60. It's easy. When you put your x's together, it's easier to move the smaller one. I get rid of a 24x by subtracting 24x. That'll take me down to 4x. And as I update, remember updating is a skill that's not necessarily always emphasized. I just realized as a teacher, kids got to know how to bring down an equal sign, to bring down the 60 that's left. And you get that far correctly, most of y'all can get rid of all of y'all can get rid of a minus 28. That's 32. And then finally, everybody can get rid of times 4, which is 8. X is 8, which I believe was the original answer before I changed it from multiple choice last night. If I plug in 8 on UW is including the 12 and the 2 times 8 plus 5. I have to plug in 8 right here to get 21 to go with that 12 for a total of 33. So maybe you got the X right and you didn't plug in right, or maybe you knew the phrase, but maybe you didn't set it up right, or maybe you didn't solve it right. Whatever your issue was, hopefully this takes care of it for you. Second question. This is a outside times whole. How do I know? It's got an outside on it. It's not talking about any arcs. On one line here, the outside is 4 and the whole line is 6. Saw some people in first period doing outside times inside. They did 4 times 2. On the other line, the outside is 3 and the whole line is 2x plus 8. Same thing. Some kids did 2x plus 5. They did inside. But how'd I get 8? 5 and 3 combined to make 8. Solving this, it does solve just a little bit funny if you picked up on that, because when you subtract 24, you get 0, which is a little bit strange, especially for a geometry problem. But as long as you plug in and you get a positive number, it's perfectly okay. Divide off the 6 and you still got an x value of 0. So again, it was outside times whole. X was 0, and I'm asked to plug in on k to m. So I'm plugging in the 0, and I'm getting a 5 and a 3. If I plugged in and I got a negative, or if I plugged in and got a 0, that would be bad, because these lines can't be 0. They have to be an actual number. X can be 0. That was fine. Again, it was a little strange, but it was okay. That was 2 of the phrases. The other 2 phrases are the arc phrases. You're either averaging them, aka adding them up and dividing them, or you're subtracting them. Hopefully you know which one is which. When you got an angle on the outside like that, that's big arc minus a little arc divided by 2. I didn't hide any numbers. This should have been fairly simple. The 185 is the big arc. The x is the little arc. The 80 is the angle. By the way, specifically, it's big arc minus little arc divided by 2 always equals the angle. Either decimals it, or actually pretty easy to solve. You get rid of divide 2 with times 2. So I'm at 160 equals 185 minus x. I'm going to subtract 185, which for a moment doesn't look good because I'm at negative 25, but my x is also negative. The negatives cancel. You can divide both sides by -1 if you want to. X is positive 25. There wasn't anything to plug in on here, so I just left the question at that. So again, it was big arc minus little arc, and we found x to be 25, and it's definitely a small arc. Might be a little bigger than 25, but. And finally, our last one, and this is the one that gets missed the most because of the last question. The phrase is to take the average. Anytime you got random angles in the middle, Like if it was perfectly in the center, that end would be 225, but it's not a central angle. They're not equal. You find these angles by averaging the arcs that go with them. They're different arcs because they're not coming from central angles. Basically, you're averaging them, you're adding them, and dividing by 2 now. Make sure you type that in correctly. Both of them are being divided by 2. I believe that came up to 158 for the angle. Note the significance of this answer. We know these angles are 158, and we know the other little ones make straight lines with them. Straight lines always add up to 180 degrees. So whatever 180 minus 158 is for these other ones will be 22, which is, again, the test question that a lot of kids will miss out of 4 phrases. They'll get the 158, fine, that's great, but the question a lot of times will ask for the other angle that goes with it, so make sure you're careful. Benefits of subscribing and being able to do multiple part questions like this, it kind of clarifies that for kids. I get those mistakes a lot less because you can see the process as a student now. You go through, you find one angle, oops, I got to go through and find the other angle now. Any questions before I leave this one? Don't forget about that. Straight lines are always 180. Big deal in geometry. Last couple questions. Don't forget about the circle equation. From the day that I was absent, left the video, but we talked about the next day. Remember, the center is always opposite of those. So the center is positive 7, negative 3. Not negative 7, positive 3. Remember, this number at the end is not the radius. This number is the radius squared. You got to unsquare it. How do you unsquare 25? You square root it, and the radius is 5. Be careful. Sometimes the question will ask you the diameter. Again, benefits of asking a multiple part question and paying the money to quizzes. If the radius is 5, the diameter is 10. Last but not least is a prep question for today. Oops, there's 2 questions left. I'm sorry. The second day of this unit, we talked about inscribed angles. This 35 is inscribed. You don't got to take the average or nothing like that. It's not randomly in the center. Its vertex is on the arc. Remember, it goes this way. I'm opening up that angle to here. If that's 35, remember, inscribed angles are always half of their arc. So this arc is 70, because half of 70 is 35. I basically did 35 times 2. What about this arc over here? I know this circle's cut in half, and it better be 180 degrees on this side. So this arc is 110, 180 minus 70. Last but not least, you're asked about this angle up here, which is opening up this way. It's opening up to the 110. And it's an inscribed angle. Inscribed angles are always half, so this angle up here is 55 degrees. Probably should have drawn that as I was saying it. So again, 35 was an inscribed angle, and inscribed angles are always half of its arc. Arc FP would be 70, because 35 times 2. Arc PD, by the half circle being 180, was 110, and then this last one was also inscribed, making that 110, aka half of 110, 55. So finally, a prep question for today. In this last lesson, we're still talking about area, or for the first time in Math 3, we're talking about area and circumference. We talked about area before. We take a middle school topic and upgrade it a good bit. If you're talking about measuring the inside of a circle, that's the area. And if you're talking about measuring around a circle, that's the circumference. So if I'm measuring the length around a circular garden, that's circumference. I'm going around the garden. If I'm measuring space that a rug is covering, that's all the area. It's not just the outside of the rug. If I'm walking around a track, that's the circumference. If I'm painting a wall, I'm not just painting the outside of the circle, I'm painting around wall, I'm painting the area. If I'm putting a fence, that would be circumference. Fences go around. And finally, if I'm cutting the grass, I'm not just cutting the outside of the circle, I'm cutting all the grass in the circle. I'm cutting all the space in the circle.